Welcome to another great recording by your teacher, Mr. Shepherd. Today we're going to be starting 5.3.4, How Can I Represent It? Using variables to represent quantities in word problems. If you haven't yet gotten a piece of paper to write on, please pause the video now and go get it. If you have a piece of paper, make sure to write these down at the top of your paper. So that you can identify which section this is for, which homework it was, which activities it was. Make sure to put your name and class period on it. Today we're going to continue using the 5D process as you guys solve word problems. You guys should recall that the 5D process was a process that we used to solve problems that off the bat we had no idea how to do them. And we went through this process of first describing and drawing the situation, thinking about what are the most important elements of this, drawing ourselves out a picture when it was applicable so that the visual would be able to help organize our thoughts. So we would define, so we think about what are the things we don't know, what are the numbers we don't know, and then we could put in some guesses. After that we had our do section. We made sure to do the math that would test our hypothesis, and then we checked. Was it too big, too small? Which direction do we need to head? Today, I want you guys to think about these questions. What is the problem asking? What is the relationship between the quantities involved? And how can I choose which part of the problem to represent with a variable? Today we're going to throw in variables. Okay, so this is problem 5-128. Make sure to write that on your paper, 5-128. This is our first problem. Mai has 1 mini box of Choco Blasters candy, and Warren gave her 3 more pieces. Samara has 2 mini boxes of Choco Blasters and gave 6 pieces to Will. Now Mai and Samara have the same number of Choco Blasters. How many Choco Blasters are in a mini box? Assuming all mini boxes of Choco Blasters have the same number of pieces in them, use the 5D process to solve this problem. Okay, so make sure that you write down on your piece of paper, this is kind of our blank form for the 5D process. Make sure you go ahead and write all of this on your paper to begin with. Make sure to give yourself enough space for the number of trials you're going to need to do. Go ahead and pause the video to give yourself time to draw all this down. Now, I'm putting this back up so that you can start fitting into the describe and other sections all the pieces of information that you're going to need to solve this problem. Make sure to pause the video if you need it to write down some of the necessary information. Okay, now what we're going to start doing is fitting in some of the necessary information that we have from our story. So let's start with describing. First, we know that Mai has 1 box and she was given 3 more. Samara has 2 boxes and she gave away 6. I apologize. After this, Mai and Samara had the same number of toys. Alright, so there's my descriptions. Now one thing I could do over here for my picture, I'm going to have two lines. Now we know they're both going to end up being exactly the same. So I could call this one my, and this one's going to be Samara. Now we know that my only had one box, and then she got 3 more. So let's go ahead and call this a box, and then she got 3 more. Samara had, and we can kind of see the problem with this, so let me change that a little bit. So Samara had 2 boxes, so we actually need to go out here even, because we're going to do something a little bit interesting. So she had 2 boxes. There are her 2 boxes. But she gave away 6. And that put her at the same level as my. So there's kind of my picture for both of them. For my define, we need to pick out what is the number we do not know. So what we don't know is the number in a box. Okay, now in our do, we're actually going to do something you guys haven't seen before. I'm going to break this up into 2 sections. We're going to have my on one end and Samara on the other. And we're going to break up the do section into 2 columns. So let's go ahead and let's just guess any number to begin with. So for trial 1, we'll say a 5. So for my, we're going to have 5 plus 3 is 8. Now for Samara, she's got 2 boxes. So if there's 5 in a box, we got 5 plus 5 minus the 6, because she gave it away, is going to give us 4. Alright, so now my deciding. What am I deciding? If my equals Samara. That's what we're trying to know. Does my equal Samara? Well, my was 8. Samara was 4. So they are not equal. And I am going to put over here off by 4. That's how far apart they were. We want them to be the same. So let's go ahead and try a new one. Let's jump up a little bit. Let's go ahead and say 8 now. And let's see if that doesn't take us closer. So now if I do 8 plus 3, it's going to give me 11. 8 plus 8 minus 6. It's going to give me a 10. So now I've got, does 11 equal 10? No, but now I'm only off by a 1. So I definitely got closer there. So 8 is definitely closer than 5 would be. So let's try another number. I'm not going to go too far because 8 was so close. Let's go ahead and try 9. 9 plus a 3. And if you've already figured it out because you paused and you just figured it out, great. Go ahead and skip. Going to give us a 12. 9 plus 9 minus 6 will also give us a 12. So yes, 12 equals 12. This was the right answer. So now we would declare that the boxes have 9. Okay, let's move on to the next one. 529. Make sure to write 529 on your paper. Alan's team was working on a problem, but did not have the time to finish it. They also did not follow the teacher's directions. Hopefully you guys notice there are a few things missing, such as we no longer have the define and describe put in here. We don't have a picture. Discuss with your team what information you can get from Alan's table below. So try and use the information that you can see to answer the following questions. Okay, so first question, is there enough information in Alan's table to finish the problem? Why or why not? So in other words, what we're trying to ask is, do you have enough information to figure out whether or not your answer is right or wrong? Can you continue their work to find the exact right answer just by what you can see here? First off, I'm noticing a few things. So first we're talking about length and width. Now they said with length and width we're going to double each side. So I see 3 and 9. 2 times 3. 2 times 9. That equaled 24. It looks like our target perimeter is 36. They had a 24, so that was too small. So if I try to continue that same work, first I see that they tried a 4, so I could do 2 times 4, but I'm not exactly sure what I'm going to put here. Now, is that another guess, or is there a specific way to use the length to get the width? I just really don't know. Can the width be any number? I don't see that information there, so I don't really know what I would put there. So I'm really not going to be able to finish this problem because they didn't give me enough information. I don't know how they went from the 3 to the 9. Okay, now question 2. What would you need in order to complete trial 2? Explain your thinking. Okay, make sure you've written down all your answers to 529, parts 1 and 2. Make sure those are written out completely on your paper. Also, when you are answering these questions online, do not just tell me answers on the paper. Type it into the computer. Okay, you guys need practice. Alright, I paid for all of my college by being able to type quickly on a computer. It's a good skill to learn. Practice it. Your keyboarding teacher will thank you. Alright, so 5-130. Make sure to write that on your papers. Alan's teammate Scott was also working on problem 5-129, so we're looking at the previous problem again. But he organized his table differently. As Scott explained his table to Alan, he then used the pattern in the first 2 trials to represent the quantities in the third row with a variable x. So, first question, how is this table different from Alan's table? You may want to take your video back to where you can see the previous problem so that you can compare what are the differences. Okay, now one of the big differences that I see as I go through, Now they're both doing length and width, but Scott is doing something unique in that he's showing me where the width came from. So 2 times 3 plus 3 when the length was a 3. When the length was a 6, we add 2 times 6 plus 3. So I can now see that one of the things he's doing is he's doing a 2 times the length plus a 3. I also notice that one of the other differences is before Alan was saying that we multiply both sides by 2 and add them together. Scott is saying that we add up all the sides. Now what we can see is that 3 plus 3 would really be the same as 3 times 2. 9 plus 9 is really the same as 9 plus times 2. So he's getting the same numbers, he's just using a different approach. So it does look to me like he's doing perimeter. He's just adding up all the sides. Both of them approached it in a slightly different way. But now I know what I'm doing with my length number. I got to multiply it by 2 and add a 3. What does x in the table represent? So you'll notice down here, we've got an x. Okay, well, right up there, it tells us what x is. X is some number representing the length. Now, we can put a whole bunch of guesses, and x could be any of those numbers. If x is a 3, here's the way it works out. When x is 3, it's too small. What about if x is 6? Well, it's too large. But by just putting in x, we can get a different kind of a statement, as you guys can see down here. And right now it looks a bit complex. Alright, let's look at the third question. In words, describe the relationship between the length and width. Alright, so what is our length? What is the relationship between the length and the width? Well, if the length is x, then the width is twice that plus 3. That's our relationship. It's clearly shown there. X is the length. So what's its relationship to the width? Well, you double the length, add a 3. Where did the expression x plus 2x plus 3 plus 2x plus 3 come from? Explain your thinking. Now, here's what I see. We're going to add all 4 sides together. So, if this were some kind of a rectangle, if the length is an x and the width is 2x plus 3, I kind of did that backwards, then what we're going to have is, well, x plus the 2x plus 3 plus another 2x plus 3. We're just adding up all of those sides. Alright, so we're looking at a new problem now, 531, make sure all the work has been written down. Izzy's team used a 5D table to solve a problem that involved consecutive integers. Now I want you guys to quickly take a look at this 5D process, identify what's missing. What did they forget? Consecutive integers that follow each other on a number line. Consecutive numbers are numbers like 1, 2, 3, 14, 15, 16, or -5, -4, -3. They all just follow right after one another. These are all examples of consecutive integers. The table below shows part of their work on the problem. Copy the table and finish the problem. After you find a solution, apply Scott's idea from problem 130 and add a row that uses a variable to summarize this problem's process. Alright, so first, write all this down on your paper. Pause the video to do so. Okay, start finding the solution to it. You will notice that our target sum is 57. Find the starting number that's going to give us 57 in the end. Alright, so now I'm going to try to continue this process. So I'm going to guess. We know it has to be between 15 and 20. So let's say this is an 18. Now we know that the second number always takes the first number and adds a 1 because, well, they are consecutive. So 18 plus 1 would be 19. So we have 18, 19. Next one would be 18 plus a 2. So 18, 19, 20. So adding all the numbers together, 18 plus 19 plus 20. 18, 19 plus 20. So 18 plus 19 is going to be 34. And 34 plus 20 would be 54. So I am too small. Just a little bit too small. So I'm going to try once more. Going to do 19, which means this is 19 plus 1, 20. 19 plus 2, 21. So 19 plus 20 plus 21. 19 plus 20 is 39. 39 plus 21 should be I have made a mistake. I want you guys to see if you can find my mistake real quick. Mistake was I added incorrectly on my guess of 18. 18 plus 19 is actually 37. 37 plus 20 is 57, meaning that that was not too small. This was our correct answer. Okay, now, next thing we want to do is to add in that section for variables that they were talking about. So we've got our section for our guesses of 18. Now let's just go ahead and say the first number is this value of x. So how do we get the second number? We get it by doing x plus 1. How do we get the third number? It's an x plus a 2. Therefore, this is going to be x plus x plus 1 plus x plus 2. Now, one thing we might be able to do if we really want to is simplify. So that could also just be simplified down into 3x plus 3. I've got 3 x's and 3 1's. Okay, 5132. Maiko saw someone's expression in the 5D process table below, and he wanted to reverse it. The problem involved a bag of green, red, and blue marbles. Alright, so make sure to write down this table. You're going to start filling it out. Try and reverse it yourself. Try and figure out if he guessed 15 first for the green, what is the red supposed to be? What is the blue supposed to be? What's the total marbles? And was it too small, too big? What was it? Go ahead and do that right now. Alright, so First it says, one of the variable expressions describes how the number of red marbles compares with the number of green marbles. How can you describe this relationship in words? Okay, so how can we describe the relationship between green and red? Well, the relationship between green and red is if green is x, then red is an x minus 2. So there must be 2 less reds than there are greens. So I would have 15 minus 2 which would be 13. Okay, next question. Based on the variable expressions, use words to describe the number of blue marbles compared with the number of green marbles. Now, each of these bullet points is a question you should be answering on your paper. Make sure to do that. Well, so I notice if x is green, then the number of blue marbles is twice the number of green. So I would write that down. Twice the number of green plus 5 more. Or 5 more than twice the number of green. So what does that mean for our guess above that we have? Well, if we had green was 15, twice that would be 30. And then plus a 5 would equal 35. So the total number of marbles would be a 15 plus a 13 plus a 35. 15 plus 13 is 28. 28 plus 35 is going to be 28 plus 35, 63. So, all right, let's look at the next bullet point. How many total marbles are in the bag? Okay, hopefully you can figure that out from what we've done. If there are 15 green marbles in the bag, how many red and blue marbles are in the bag? Use this information to find the number of green, red, and blue marbles. I now want you guys to use his equation to finish this up. If you're done with this video and you've written down all your answers, go ahead, grab a book. There are some more questions in section 5.3.4. Go ahead and give some of these a try. Okay, if you've reached this point before the end of the class and you've written down all your work and you've answered all your questions both in the computer and on your paper, it means you've done an excellent job and you're ready for some more challenging problems. Go ahead, grab the book, try some of these out. You may now also work with some other partners who are at your assigned table on figuring these out. Thank you for some good work today.